Ever since Apple TV released the haptic trailer for F1 movie, I was fascinated by the idea of using vibration motors in our mobile phone to enhance the video viewing experience. If you haven't watched it, do check it out. It's streaming for free on Apple TV. But there is a catch. If you are using an Android phone, you will not be able to experience that rich haptic video viewing experience. It's exclusive for Apple devices only as of now. Even though Android phones are having a vibration motor, there is no attempt has been made towards making a haptic video experience to Android. So in this video, let's break it. Let's build a completely functional media player for Android which is able to give you a haptic video experience on Android. So let's jump right in. Before we jump in and start coding, we need to understand some basic fundamental concepts about how multimedias are processed on electronic devices. So let's start with topic number 1, that's metadata and codecs. So what is a metadata and what is a codec? Let's think of the MP4 files that are inside our mobile phones or PC. MP4 files are what we call as a container format. Just as the name indicates, it is used to contain some other items. You can think of MP4 files as a basket of apples and oranges. And apples and oranges are nothing but encoded videos and encoded audio. So inside an MP4 file, there can be a raw video that is compressed using one specific codec, and there can be an audio that is compressed using another codec. And these two items are integral part of an MP4 file. And there is another guy sitting inside the same MP4 file. That is what we call as a metadata. And what is a metadata? Metadata is nothing but a label that we stick on top of this basket. From this metadata, the video player will understand on how to deal with the encoded videos and audios that are inside the MP4 file. That is how it is done. The metadata plays a very critical role in how the video streams are handled by the electronic devices. Now we have a clear understanding of what a metadata is, what is the role of a media player in parsing a metadata and decoding and encoding the video codec, and so on and so forth. We have a better idea on how those things actually work. Now let's take a moment to understand how Apple might have implemented their haptic system. First things first, it's just a metadata game. We can add anything into the metadata. We just need a proper formatted parser on the other side, on the video playing side, to unpack those metadata and make the cues. So that's how Apple have done this. They have added some additional metadata into the video playback so that their media player can parse those information and trigger the vibrations on their device. Let's see an example. Let's say I have added something like this onto the metadata. What this actually means is start vibrating the motor for 300 milliseconds with an intensity of 100 when the media starts playing at the 0th second. So by adding that line on the metadata, and if the video player can actually parse that information, then the media player is having an information to do an action. That's how Apple have done this, and that is exactly how we are going to do the same thing. On doing further research, I came to understand that Apple is using a file format called AHAP. AHAP stands for Apple Haptics. So each video stream is actually incorporated with this AHAP information so that the media player can actually pass the information in this AHAP file and create cues for vibration metadata. A AHAP file would look something like this. On taking a closer look into the AHAP file, you can clearly understand that they have classified each vibrations into events. Each event has a type, parameter, and a timestamp. Basically, each event defines a sequence of vibration patterns. Inside their library, they likely have a pre-composed vibration pattern saved, which are configured using the parameters received in this event. Long story short, the media player parses the AHAP file and creates cues for each event and triggers them when the timestamp matches the video playback. This is my understanding about the Apple's haptic system. They might have done it on some other ways, but this is something that came into my mind when I see the AHAP file format. So this is completely my narrative. I don't know how they have done it, but I'm pretty sure that this approach will work just fine for our Android app. Let's move on to the next ingredient, and that's metadata. For the metadata format, I plan to reuse the already existing SRT subtitle format. My plan is simple. Haptic data should be treated just like subtitles. When you load a subtitle file, if there is a haptic data inside, the motor should vibrate. My format would look something like this. First, there will be a header which look like this, which tells the player to turn on the vibration engine. Then the events. Events will be recorded in this format. Initially, I used a different metadata format which looked like this. This one gives the starting time, ending time and the intensity of vibration. But when I implemented a system using this pattern, what happened was the vibrations was so discrete. There was no life to those vibrations. That's when I started to do more research about Android APIs, vibration APIs, and I read about these APIs. The point is Android itself supports multiple primitive vibration patterns, and these patterns are continuous, smooth, and so refined. Android also supports stacking these primitive vibration patterns and creating our own custom vibration patterns. So this feature has been a lifesaver for me. I created nearly 23 common sound effects like thunder, explosion and rumbles by stacking these primitive vibration patterns. As we have already figured out the two critical ingredients of our system, let's move on to the last and the most critical part, that's the media player. So our video player should be able to parse our custom metadata and trigger vibration APIs. These two are bare minimum capabilities that we need to implement. So I choose the already existing open source, the goated VLC media player. Why I choose VLC media player? Just because it enables us to load subtitle files on the time of playback, and it synchronizes with the playback automatically, and it's open source. Since we are following the SRT format for haptic files also, this feature would be handy. So synchronization, parsing and SRT parsing is already being done in the VLC media player. So we just need to clone VLC media player and then make two additional changes. That is, we need to add our custom metadata parser, and then we need to add our vibration manager. So with these two simple implementations, we would be able to make a haptic media player for Android. Enough story, let's jump into coding. VLC Android is the official repository for the Android VLC app. My plan is to clone this repo and find where the subtitle parsing is done, modify that section and add my vibration manager. After cloning and going through this code base, I found that this function is responsible for adding the subtitle tag, just as the name signifies. There exist two different signatures for the same function. One is for parsing from the local file and one is for parsing from URL. I have added same modification for both signatures, but the URL version is not tested. Set a vibration from SRT function basically creates an instance of the vibration subtitle manager class. This class defines everything related to our vibration system. The file is nothing but a collection of vibration patterns. Honestly, most of them is generated by ChatGPT. Load SRT from URI. This function will call the load SRT text function, which will basically parse the SRT file using the regex string we declare and create queues for each vibration events. Once the queues are parsed and instantiated, we call play pattern function, which is basically a switch case which will call corresponding functions for vibration patterns. These functions implement the core functionality and the remaining functions are simply some checkers and helpers. These start, stop and pause functions are required by the VLC to basically tell what to do when the user do certain actions. That's it. It should work minimally. I am not good at Android app development. In fact, this is my first experience with Kotlin and Android app development. With that said, let's build the VLC for Android. Building VLC Android requires Ubuntu machine and certain versions of Java, Android Studio and Android SDK. It took some time to install them and get the build environment ready. After compiling and building the app, you will get the debug version of the VLC in the application builds directory. Let's not build the final release version since the code I implemented is not cleaned up or not perfect, but it works. I manually created the SRT file in the predetermined metadata format. Now let's install the VLC modded app in my Samsung S23, which you might have already noticed from the green lines. After installation, let's play Big Buck Bunny and load the SRT file and feel the haptics. Actually, it works better than I expected it to be. Usage of primitive patterns actually increase the haptic experience. As someone coming from an embedded systems background, I found it really hard to develop a mobile application. So it is not perfect, but it works. The changes I made is little, but learning behind it is huge. I try to share everything I learned in this video. I hope everyone learned something new. I know there are really great app developers among you. I wish this video was able to create a spark and people continue building better media haptic systems for Android. Why should iPhone have all the fun? The modified code base and the SRT file I generated for Big Buck Money is available in the GitHub repo. If anyone want to take up this and implement a better haptic system, you are always welcome. Please subscribe if you like this kind of content and see you next time.